Hello and welcome to Build Propulsion Lab at DPE, Developer Productivity Engineering, tour in London. Roberto Perez with me, a dear friend, dear guest for repeating guest at Build Propulsion Lab. You probably remember we spoke at DP Summit, Roberto is with Netflix. Thank you for joining, of course. The topic that we want to discuss is something that we kind of tagged as build lifecycle observability. Now, being an ex-DevOps guy, I know observability, it's about observing your production systems.
Yep.
But now we're talking about something else.
Correct. Yeah, talking about builds, and specifically, we're going to talk about JVM builds. So, long story short, I'm Roberto Perez. I work at Netflix in the JVM ecosystem team, and what we do is provide all the kind of tooling that a Java engineer might need to produce Java software. And part of that is the build tooling. Many people might be familiar with those tools, for example, Gradle, Maven, and many others. And the reality is that engineers over the years, they tend to focus more into the feature aspect, the frameworks that they use, but not so much about the build tooling, right? So at some point, it's like, my build is slow. Why is this thing like that? There is no easy tool to understand that other than looking at logs, when I'm spending this time. And this is where things like build scans and Develocity come into the picture, at least for us.
Let me be a little bit of a devil advocate here and say that, you know what, as a developer, I don't care about build. Really, I really don't. I want to write my business logic, as I don't care about the internals of the JVM. I don't care about build. As long as it's not code, all I needed for it is just work. So obviously, I won't pay a lot of attention to it, as long as it's not failing and it's not in my way. And when it is failing and in my way, then I'm just upset with it and I don't really know what to do.
That's a fair point. I think it's very common, but I will kind of counter-argue that a little bit. Like, if you think about it when it comes to productivity overall, as an engineer, you spend most of the time, hopefully, after you like it, like writing code, compiling, testing, right? So compiling and testing are two huge part of building. So if that tool chain is slow or not efficient as it could be, well, you're basically like paying the productivity tax, right? And I know that not many people are fond with build tools, so that's fine. You will have always champions within your teams, or hopefully a dedicated team, but not every company can afford that. But still, when things go wrong, you need to understand a little bit of that in order to know what's going on, right?
Okay, so we have a situation there which is not great, right? From one side, as engineers, don't want to know about build. From the other side, as you just mentioned, it's really critical for productivity to care about build. So what do? How can we make the what's going on in the build lifecycle approachable for developers?
Yeah, I think it's many things here. Like it goes from the build tool itself to also be easy to use. Like typically these tools could look overwhelming and complex because you can do many things with them. And that's where engineers in your company come into the picture, where they can abstract away easy tasks. Like as an engineer, I don't want to go and write Gradle plugins or Maven plugins, whatever it might be, to publish, to package, to do whatever. I just want to build my code, right? So that's when you can create things for the whole company and make things easier for those engineers to more streamline, like you say, DevOps, right? So you create all the CI/CD pipelines, and build is also one aspect of that. So if you start abstracting away that complexity from engineers, they're just gonna care about, okay, what dependencies do I need? What are the things that I should be doing in my project, and move on. But then when you have that kind of level of control, let's say, you can start getting insights. You can be opinionated, and you can start getting that those metrics to tell you, okay, this is the build lifecycle health in my organization. I know that the builds are taking X number of minutes across the company. And if you got something like build scans or the velocity to aggregate all this data, then you can take informed decisions. And by that, I mean, like, I know I have this particular project that takes 50 minutes to build. Where is that thing happening? Is it compiling? Is it running tests? Is it something that it's not supposed to be doing? When you get this information in front of your face, then either as an engineer or a leader or whatever that might be, you can come and say, hey, you know what, this is dragging us the productivity. We can spend some cycles here and make life better for everybody.
So, is it something that is only should be on top of the minds of those special people that you mentioned, the champions or the special teams, or is it something that all of the engineers not only should care about but should have approachable and simple way to both observe and take action upon?
Um, to be honest, because I work on a build team, I will tell you that every single engineer should have some knowledge of this. It's very important that you understand how the pieces of code that you are creating get packaged in a sense. You don't have to be an expert, but at least you need to understand a little bit like what's happening under the hood. Like at the very end, you don't want to become the person that only writes feature code and not understanding the whole life cycle. Because today in your company, you might be working with that and then you switch jobs. And what happens if you land in a job where you need to do everything? Now you don't have that level of expertise. Like you mentioned DevOps, right? So CI/CD, many people are abstracting those things away, making it easier for folks. But some folks are missing how things work under the hood, like compute abstractions and stuff like that. Similarly with build, if you don't understand that, you can get into the point in your career where it's going to be difficult to ramp up again in this topic. So always keeping up to date with what's happening in the space. It's great in all aspects of the tool chain.
And it's actually a perfect analogy, I would say, with understanding of how everything works in DevOps. So we spoke about it many times. Like, hey, do I need to know everything that is going on in your Kubernetes cluster? No, you don't. But you don't need. But you do need to have a fair understanding of what a container is, right, and how the Docker build image works. And when you have access to those observability tools on your production platform, you need to understand what you're looking at, right? And now if we take the same concept and bring them into build lifecycle, this is where build lifecycle observability kind of comes in. And what's that? What does it mean for the engineers to have this kind of observability, what we can observe, what we should observe, what we should pay attention, and how do we do it?
Yeah, that's a good question. If we kind of try to translate the same analogy into this, think about it like if you were looking at the build tool, you probably don't want to be an expert on the C2 compiler to see how that Java class becomes bytecode. You probably don't want to be an expert on the dependency management machinery to know how you select a certain version. You probably don't want to be an expert on how JUnit works under the hood to launch tests, right? But you want to know when things go wrong in those three levels. So now the level of information that you might want to get is how much time am I spending compiling my code? How much time am I spending resolving dependencies, downloading dependencies? How much time it takes to run tests? Do I run that in parallel? Do I not? So understanding really more of the execution layer will give you the right insights or the starting insights to take action on how to improve things overall.
Okay, that makes sense. And when we're talking about like, okay, so how do we start? Where do we go? Let's say I want to establish this kind of observability into my build cycle. I want to know on a team or organizational levels what's going on in my build, if they're slow, if they're failing, if they're flaky tests that people are just annoyed but won't necessarily talk about it or take the time to fix because they pass eventually, so just rerun them. But obviously, in the long run, it impairs productivity. Yeah. So where do we start in building this kind of observability for our build lifecycle to be on par with the observability that we have for our production systems?
Yeah. So I guess the starting point is usually CI. People will start looking into how long it takes for a given job or CI build to run. But honestly, that will tell you all the amount of time, right? It won't tell you the deep level details that we want to know. And that's where things like build scans become very powerful. So to be honest, at Netflix at the beginning, we were running our own like Gradle plugin to collect metrics. And at some point, we noticed that it was a lot of effort just to keep up to date with the tool versus using something that it was more robust and also a better UX, right? So we're like, hey, let's start using build scan, let's aggregate this data. So we have the machinery in place to apply plugins by default to people. So internally at Netflix, you don't use open source Gradle, you use like an internal wrapper that basically provides the default opinions, and that includes publishing this information. So when you think about it, this can be very powerful, and it's not as difficult as it sounds. Uh, you can just go and say, hey, this is how you use Gradle here. You can apply these plugins, and these plugins will be responsible for doing many things, including publishing the insights. And then when you aggregate all this information, then you will have a clear picture on what's happening across the company.
Okay, so that makes sense. So the first step is collect the information.
Yep.
And you collect the information using Gradle bin scans. It's basically a dash scan for Gradle builds, and like also like a very simple configuration for Maven. And then the data starts to kind of flow in.
Yep.
Right, you start to collect the data, and that will be your, if we keep with the APM analogy, that will be your agents that you now enabled, and they start to collect the information. Next, what do we do with all the info that we collected? Both on practical level, how do we look at it, and on a more a general abstraction of what should we look for and how should we act?
Yes, so I think you should start looking into trends, and trends in the three aspects that I mentioned. One is how long it takes for my project to get configured, how long it takes for my project to download and resolve dependencies. That's one of the biggest pain points in the Java space. And obviously, how long it takes to run a particular test suite. Those are the three major things that we have seen hitting productivity for engineers in the last few years. With things like Develocity, you can definitely aggregate information by project, by teams. You can put any kind of a tagging that you might want. So one of the powerful things about build scans in particular is that you can provide your own tags or custom values. So at the end, you can kind of reflect the kind of project you are building. So you can do something like, hey, I want to get the trends of build times across all the projects that are using Micronaut, for example. So you can tag Micronaut for all these builds, and then you can see, okay, this is a spiking, and then start digging into why. So when you start digging into that, you can see, okay, probably this is because of test. And this is how we at Netflix discovered that most of engineers were spending more time waiting for tests to get executed versus dependency management.
And that was exactly the question that I wanted to ask. All right, so here we go. We collected all the info with BuildScan, and now we look at it in the BuildScan UI or in Develocity, which gives you like more information there. And you went through that with Netflix. Give me one anecdote of like the most wow moment. We had no idea that this is happening, and thanks to all the observability, now we know.
Yeah, that's a great question. I will say that the test was not surprising. We knew, we just needed the data to confirm, like we wanted to invest on that.
And that's like the tests are very long running.
Long running and not parallelized. So what we learned is that forcing people to do parallel mode in Gradle is not as easy as it sounds sometimes, because you have compute resources in play. It might work, it might not work. So what we learned is that because we made this an opt-in feature, not many people were using it. And we're just kind of like looking at the aggregated picture, like, oh, more than 60, 70% of our builds are not using parallel mode. That's like, oh, that's a feature flag that you can turn on, and you get like productivity boosts right away. And then you deal with, the difficult problems, like the ones that really rely on compute resources availability.
And I guess also dependencies between tests.
Yes. Yeah.
That generally folks don't do that, because you won't be able to run them in parallel, and it will slow your build significantly.
Yep. So just start getting all this data. You start understanding what features are being used from the build tool, how the execution layer actually is. So the product has been getting better by the day. So before you will only get like, hey, these are the tests that you run, but at this point you can also understand like how many threads that you launch. And then you can look at things like, okay, you know what? I'm scheduling these particular CI jobs on these beefy machines, but I'm not even parallelizing. Like I'm just wasting compute money or compute resources, which means money to your company, right? So even when you look at probably you don't want to spend time in productivity in the build level, but you want to spend time on reducing your cost operation. When you start looking into this aspect, like how can I squeeze the compute resource, then this is very powerful also for driving those decisions. Let's say that you have a project that only needs like 4 CPUs. Why are you running that thing in a massive like 16 CPUs machine that costs you like four times more, right? So it's the land of opportunities.
And again, this is not something that you would see without having this observability on
Yes.
your build life cycle.
Yeah, you will have to build your own. You need to like it. I know it's that you need to measure first and then take action, unless you really have a good understanding of ecosystem and go blind. And sometimes you will get surprised regardless. So yeah, measuring and then taking informed decisions is the way to go in these cases.
That's great. Roberto, as usual, tremendous pleasure to chat with you. Thank you very much for this great insights. And I personally look forward to see you on stage tonight. And you all stay tuned. We have a lot more interviews here in Build Propulsion Lab at DP2 in London.